Hey, good people, how are you? This is Trockers. I guess you are doing well wherever you're watching from. Okay, so today we want to explore a question on matrices. Okay, this is from ZIMSEC November 2025, paper one. The question reads, it is given that P is equal to 1, 1, 2, 2, negative 1, 1, 1, negative 2, 3. Find the inverse of P, hence or otherwise solve the following equations. Right. So with this particular question, guys, on part A, we need to evaluate the determinant using any of the methods. So I'm going to evaluate the determinant using three methods: the basket weave, the method of cofactors, and multiplying the matrix by its adjacent or adjoint matrix. Then on part B, hence or otherwise. So hence, it means we can use the matrix method, or otherwise we can just solve these equations simultaneously. All right, so without wasting much of our precious time, let's go ahead and get started. All right, guys, so we are given this matrix P is equal to 1, 1, 2, 2, negative 1, 1, 1, negative 2, 3. So like what I said, let's do the determinant first. Okay, so for our determinant, the first step to do, we want to find that P. So our determinant P, so it's just 1, 2, 1, 1, negative 1, negative 2, 2, 1, and 3. All right, so what we are going to do here, I'm just going to add the first two, the entries on the first two columns here, right? Then from there, we have, let me use the blue one. All right, so we have these top, bottom diagonals, right? So you have to make sure that each diagonal contains three elements. So here, right, here, and there, right? So let's just multiply 1 times negative 1 times 3. This is negative 3. 1 times 1 times 1, that's 1. This, that's negative 8. So when I sum all these up, I'll get negative. So the total here is negative 10, right? Then I'll do the bottom top diagonals. So I have this, I have that, and I have that. And again, when I multiply, I'm getting negative 2, I'm getting a negative 2, and I'm getting 6. So if I sum these up, I am going to get positive 2, right? So when I get positive 2, for basket weave, we know that our determinant here, determinant is just, okay, determinant of P is equal to these the blue diagonals minus the sum of elements along the red diagonals, right? So it's just negative 10 subtracting 2. So our determinant is negative 12. So this is one of the methods we can use. Let's see the other method. So the other method, guys, is the method of cofactors, right? So allow me to rewrite the matrix down here so that I don't need to scroll up and down. So 1, 2, 1, 1, 2, negative 1, 1, negative 2, and 3. All right. So the method of cofactors here, you just choose either a row or a column to work with. Right. So for this one, unfortunately, we don't have 0. So normally, if we had 0 elements there, that's the column or row I would pick. But here, let's just go ahead and use the first row. Right. So when finding the determinant here using the method of cofactors, what happens is that I have to multiply. So if I choose this one here, so I'll just have to multiply negative 1, right? Negative 1, then it's going to be negative 1, then I plus j. I represents the row, j, the column. So here, this one is first row, first column, so I'm going to add, right? Then I'll put the 1. So you have to delete the row and the element, the row and the column in which that element lies. Then you write down the 2 by 2 matrix, the remaining, 2 by 2, yes, matrix. Then you're going to find the determinant for that. Then here plus negative 1, you do the same. It's going to be, so for this one, it's first row, second column. then it's being multiplied to 1. So if I delete this, I have 2, 1, 1, 3, then plus negative 1 to the, so this one is uh, third column, then I have a 2. So if I delete that and that, I will remain with 2, negative 1, 1, and negative 2, right? Then we know that when multiplying this is just positive 1, so it's just 1 times whatever we're going to get here. Then this is minus 1 times whatever we're going to get there. Then this is positive 2 times whatever we're going to get there. So we know that when finding the determinants, it's just AD minus BC. So it's negative 3. So here it's negative 3 subtracting negative 2. And here it's going to be 6 minus 1. And here it's going to be negative 4 subtracting negative 1. Right. So now when we do that, negative 3 plus 2, that's negative 1. Then here 5. Then here negative 4 plus 1, that's negative 3. So it's going to be negative 1 minus 5 minus 6, which is equal to negative 12. So we still get the same answer, which is negative 12. Right, so our determinant is negative 12. Like what I promised you earlier, I am going to use the other method where I will multiply the matrix by its adjoint. So when you multiply the matrix by its adjoint, the result should be of this form. Determinant of P, then all other elements are 0. So here, the diagonal elements, like it's a diagonal matrix where the element here is just your determinant, the value of the determinant, right? So if you get this, then it is going to confirm that, the determinant. 1 is going to confirm our determinant, and number 2, it's also going to confirm if the adjacent matrix is correct. Right, so now let's move on to finding the adjoint matrix. It's called adjoint or adjacent, so either way it's fine. So I have my P here, which is equal to 1, 1, 2, 2, negative 1, 1, 1, negative 2, 3. Right, so guys, first we need the matrix of minors. Right, so here our matrix of minors, I'm just going to write it down here, but I'll find it here. It's going to be a big matrix, right? So you delete the element and the row in which that first one lies. So we remain with negative 1, 1, negative 2. So if I do this, negative 1, 1, negative 2, and 3, right? Then we do the same. We have, if we do the same, we have 2, 1, 1, 3. Then when we do the same here, we have 2, negative 1, 1, negative 2. Right, we are done with this. Then we move on here. I have 1, 2, negative 2, 3. Then if we do the same, I have 1, 2, 1, 3. Then if we do the same, I have 1, 1, 1, negative 2, right? Then for this one here, I'm going to delete the row in the column. So we remain with 1, 2, negative 1, 1. Then when you do that, we remain with 1, 2, 2, 1. Then when you do this, remain with 1, 1, 2, negative 1. Right. So there's one thing that I need to show you guys to confirm if you've done the correct thing. You see this 1, negative 1, 2, 1, 2, negative 1 is this one here, right? Then 1, 2, 2, 1, 1, 1, 2, 1, 2, 1, 2, 1, 2, 1, 1 is here. That's good. Then negative 2, 3, 1, 3, 1, negative 2 is this one here. Then, okay, this is correct. Now, let's go ahead and calculate the determinants here. So it's going to be negative 3, minus minus 2. So negative 3 plus 2, that's negative 1. Then 6 minus 1, that's 5. Negative 4 plus 1, that's negative 3. 3 subtracting this is positive 7. 3 minus 2, that's 1. Negative 2 minus this, that's negative 3. 1 minus negative 2, this is positive 3. Then 1 subtracting 4, that's negative 3. Negative 1 minus 2, that's negative 3. So our matrix of minus is going to be -1, 5, -3, 7, 1, -3, 3, -3, -3. Right. So we know we have our matrix of minus, guys. Then from there, we have to find the matrix of cofactors. So to get the matrix of cofactors, first write the matrix of minus here. So we have -1, we have 5, -3, 7, 1, -3, 3, -3, -3. Right. But we need to generate a pattern. We have a pattern. Some of us, we are good at memorizing, but I'm not good at memorizing. So I want to explain how we can get that matrix part, the matrix pattern here. So to get that matrix pattern, you need to know, because it's going to be plus, negative, plus, negative, plus, negative, plus, negative, plus. But you need to understand what's going on. Remember, we had this, we had -1, then I plus j. So I row, j column. So -1, so it's going to be 1 plus 1. So this one is going to be -1, first row, second column, -1, which is first row, then third column. So if I plus j is even, it's going to be positive. But when I plus j is odd, then that's negative. So this is what's happening here. -1 to the 2, so that's positive, negative, positive. In this one, if you want to check, it's going to be -1. So this is a second row, but first column, so that's odd. Then this one, it's second row, second column, and this one, it's second row, but what? Second row, sorry, this is second row, second column, yes, so second row, then third. And in this case, you see, that's odd, which is negative. And this one, it's going to be third row, first column, positive. Then this one, it's going to be third row, second column, that's odd. Then this one, it's going to be third row, third column, then even, which is positive. So now we are going to multiply these by the sign pattern here. So it's going to be positive, negative, positive, negative, positive, negative, positive, negative, positive. So when we get that, therefore our matrix of cofactors now is this one with affected signs. So it's going to be -1, -5, -3, then -7, +1, then +3, then this is 3, this is 3, this is -3. Right. So we have our matrix of cofactors here, which is -1, -5, -3, -7, 1, 3, 3, 3, -3, which is correct. So now, guys, once we have this, to get the matrix, the adjoint matrix, so to get the adjoint matrix here, so which is our adjoint of P, what we simply do is to transpose this. So by transposing, we are interchanging rows and columns. Rows becomes columns, columns becomes rows. Right. So here, when you transpose that, you are going to get -1, -7, 3. So first column becomes first row, or first row becomes first column. So here, this is now -5, 1, 3, and this one, this is -3, 3, -3. So this is our adjoint matrix, which is -1, -7, 3, -5, 1, 3, -3, 3, and -3. Right. Remember, I promised you that we can find the determinant using the other method where we can multiply, whether pre or post multiply the matrix by that. So let's see. If I say A times adjoint of A, this was P, right? Sorry. So P times adjoint of P is equal to what? So our matrix P was equal to 1, 1, 2, 2, -1, 1, 1, -2, 3, multiplied by that, -1, -7, 3, -5, 1, 3, -3, 3, -3. So when you multiply here, let's see what we are going to get, right? Okay, so here, if I say row by column, so this is -1 minus 5, that's -6 minus 6, which is -12. Then -7 plus 1, that's -6 plus 6, that's 0. Then here it's 3 plus 3, 6 minus 6, 0. Then -2 plus 5, 7. Sorry, -2, right? Row by column. So this is -2 plus 5. That's, what did I do here? So this is 2 minus 1, 1, 1, -2, 3, right? Then here it's going to be 1, -5, -3. So when I say row by, oh, sorry, I was at the wrong element. So it's row by column. So this is -7 plus minus 1, that's negative what? Sorry, this is row by column, right? Row by column. I got this row by column. So we're done. Okay, so first one here. Okay, so when I do it this way, let's see what I'm getting here, because it must confirm that. So we have -5, 1, and 3, -1, -7, 3, -3, 3, 3. Then our matrix, it was 1, 1, 2, 2, -1, 1, 1, -2, and 3, correct? So when I do this and that, I got that, right? So what about this and that? So it's 2 times -1, that's -2, plus 5, okay, minus 3, that's 0, okay. Then this is -7, -2 times this row by column. So this is -14, -1, so that's -1 plus 3, which is equal to -15 plus 3, that's -12. Okay, to make sense. Then 6 minus 3, that's 3, minus 3, that's 0. Then here, that's 1 times that, that's -1, 10, right? 1 times 1, that's -1, plus -1 plus 10, that's positive 9, minus 9, that's 0. Then here, that's -7 minus 2, that's -9, plus 9, that's 0. And here, that's 3 minus 6, that's -3 minus 9, which is -12. So like what I said, it should be a diagonal matrix. So this value here should be our determinant, is -12. So everything is correct. So now, therefore, to find the inverse is just -1 over 12 multiplied by -1, -7, 3, -5, 1, 3, -3, 3, -3. So you can either leave it like that, or, so normally I prefer to make it positive, or you can just say it's 1 over 12, right? Okay, so, or here P inverse is equal to 1 over positive 12. I'll just factor in the negative, so it's 1, 5, 3, 7, -1, -3, right? So here it's -3, -3, and positive 3, right? This is our inverse, 1, -7, right? Okay, 1, 7, -3, 5, -1, -3, 3, -3, and positive 3, correct? So now we have our inverse here. Let's move on to part B of the question. So part B of the question is now hence or otherwise. So I'm going to use the otherwise method here. I mean the hence method here, right? So allow me to move this up, okay? So we have our equations x plus y plus 2z equal to 0, 2x minus y plus z equal to -3, x minus 2y plus 3z equal to 5. So what we're going to do is we are going to pre-multiply by the matrix of the coefficients. So coefficient is 1, 1, 2, 2, -1, 1, 1, -2, 3. Then we have a 1 by 3 here, a 3 by 1, which is x, y, z. right, is equal to 0, -3, and 5. So as you can see, this is our matrix P, right? So to save time, we just say P x, y, z equal to 0, -3, 5, right? But you know that to get rid of this, you pre-multiply by the inverse. So you're going to say P inverse P of x, y, z. You do it on both sides, right? 0, -3, 5. So when you multiply a matrix by its inverse, you get an identity, right? An identity 3 by 3 identity matrix, x, y, z equal to P inverse of 0, -3, 5. If you multiply the identity by any other matrix, it doesn't change. So x, y, z equal to, here it was 1 over 12. Let's see the inverse. So our inverse, it was -1, -7, 3. Then, sorry, not -1. All right, so our inverse, it was 1, 7, -3. Then 5, 3, -1, -3, -3, and 3. Right, so now being multiplied to 0, -3, and 5. Okay, so when we multiply here, when we multiply, we're going to get x, y, z is equal to 1 over 12. So let's see what we're getting. 0. So here, this is -21 minus 15, which is -36, if not mistaken. Let's see. 7 times this, that's -21 minus 15. This is -36. Then, so this is just 3. 3 minus 15, that's -12. Then this is 9 plus 15, should be 24. 24, right? So we divide that by 12. We get -3, we get -1, we get 2. So therefore, x is equal to -3, y equal to -1, and z equal to 2. Right. And it's something that you can confirm, guys. You are in the exam, you want to find out, or you want to verify if your answers are correct, the numerical values for x, y, and z. You go back to the equations, right? You go back to your equations here and see, because we got, in this case, we got our x as -3, y as -1, and z as 2. So you can just plug in to see, right? So here, -3 minus 1, that's -4, plus 4, that's 0. So it's correct. It satisfies that. Then here, -6 plus 1, that's -5, plus, plus 2, that's -3. It's correct. Then here, that's -3 plus 2, that's -1. -1 plus 6, that's +5. So our values are correct. So guys, make sure you practice on how to find the inverse of matrix, and also you need to know the steps. Remember, when you find the inverse, you need the determinant, you need the matrix of minus, matrix of cofactors. We transpose it to get the adjunct or the adjoint matrix. Then from there, you know that the inverse is 1 over the determinant times the adjoint matrix. Otherwise, we should be good to go. Then on part B, when finding or when solving systems of equations, what you need to do is just to use the matrix method. You pre-multiply both sides by the inverse. Then from there, I think you should be good to go. I don't know if maybe I'll try in the next videos, I'll try and find another matrix whereby if you are given, say, matrix A and B, then you multiply those matrices together, then you're going to get that diagonal, matrix with the same value like in the diagonal. Then you should know that those two matrices are inverses of each other, because I mean, you should know that one of the matrix is the adjoint matrix. Then from there, you should be good to go. Right. I'll try and bring that question out maybe in my next videos. With that being said, guys, I'm signing out. Take care.